Dear student of class 11, now from after the completion of APGP, now I'll start another chapter that is called complex number. And most of the schools, they have already finished this chapter. Right now I'm doing this chapter. Now the complex number, the name of the chapter. Now what is complex number? And before the complex number, you should have a concept of imaginary number. Now, in this chapter, the chapter name is complex number. To do this chapter, you should have a concept of imaginary number. Imaginary number means under root negative quantities are called imaginary number. What is imaginary number means? Under root negative quantity like -1 under root negative value. Till today, the value of under root negative quantities are not yet discovered. Under root -1, under root -2, under root -3, and so on. The root of negative quantities are called imaginary number. It's very difficult to write these things while solving the numerical. So in mathematics, it is represented by imaginary number is represented by I. I means imaginary number, or we can say iota, imaginary number. And I is equals to under root -1. You just have to remember this value, the value of I. I is equals to under root -1. If you square both the sides, squaring both sides, what you'll get? I square is equals to under root -1 whole square. Then I square is equals to -1. The value of I square. Now this one is the value of I square. The value of I is under root -1, and the value of I square is -1. Now we'll discuss the theory of complex number today. The numerical, I think I'll start from the next video. I square equals to -1. Then how to represent this? -2 under root -2 in terms of I. Now then, we can write this under root -2 as under root -1 into 2. Under root -2 means we can write under root -1 into 2. Then we can separate the root over here, under root -1 into under root 2. Then under root -1 is I, root 2. Can represent under root -2 like this. Similarly, under root -3, you can say this under root -3 is under root -1 into 3 equals to, can separate the root 3. It is I root 3. Then now after knowing all these two facts, now under root -1 directly we can write I root 5. This is I root 5. Now this is just how to write the imaginary number. Now the simplification of imaginary number, suppose then I is equals to under root -1, I square equals to -1, then what will be the value of I cubed? It's a simplification after. This concept is very, very important, the simplification of imaginary number. I cubed, the value of I cubed. Now say, in case to if you ask to calculate the value of higher power of I, always try to convert the higher power of I in terms of I square. Always try to convert the higher power of I in terms of I square. So I cubed means we can write I square into I. I cubed means I square into I. Now what is the value of I square? I square equals to -1. So we can put over here -1. -1 into I. And the value is -I. Then what will be the value of I to the power 4? I to the power 4 we can write I square whole square. I square whole square, 2 to the 4. Now I square is -1 whole square equals to 1. The simplification of I. Now similarly, if you have to calculate I to the power 15, then how you are going to calculate? The nearest multiple we will calculate I square to the power, let us suppose 7. 7 to the 14. I square to the power 7 is I to the power 14 into I we can write. I square to the power 7 into I. Then I square, the value of I square is minus 1 to the power 7 into I. Negative number to the power odd number is always negative 1 into I. The value of this one is minus I. I think you're observing these things. Now say I cubed is minus I. Similarly, if the index is odd, you'll get minus I. If the index is even, you'll get 1. Similarly, I'll do I to the power 20. Definitely our answer is 1 because it is even. Now say I square to the power 10 minus 1 to the power 10 is 1. But I to the power 25 is odd, definitely we'll get minus I. I to the power 25 is I square to the power 12. 12 2s are 24 into I. Minus 1 to the power 12 into I. Minus 1 to the power 12, it is even, it is 1 into I is sometimes I, sometimes 1. If it is odd, even odd. Hope you understand these things, the values of I, how to express the values of I. Now this is for imaginary number. Next we'll discuss what is complex number. Complex number. The complex number is represented by Z. Complex number is represented by Z, and the complex number we can write like this: A plus IB or A minus IB. These two are the example of complex number where A and B are real. Where A and B are real number. Now the definition of a complex number: a number containing imaginary number like I. Number containing imaginary number with the real numbers. Real means number system. A number containing imaginary number with the real number. If it is attached, if I is there, means it is I with some real number, means it is a complex number. And this is a general form of complex number. Now next we'll discuss the properties of complex number. Now dear student, let's discuss the properties of complex number. Number 1, let Z1 is equals to A plus IB and Z2 is equals to C plus ID. These two are the complex number. Now say, we can add this to complex number, we can subtract this to complex number, we can multiply this to complex number, we can divide this to complex number. So, first property, number 1 property, subpart 1, addition. Z1 plus Z2, addition of the two complex number, A plus IB plus C plus ID. Now then we can write the real quantity, real plus. Now from these two expression I'll take I common, that is imaginary. This is another complex number. Number 2 property is the subtraction property, Z1 minus Z2. A plus IB minus C plus ID. A plus IB minus C minus ID. Which is A minus C. Take minus I common, it will be B minus D. This is another complex number. We can add, subtract, we can multiply also this complex number. Z1 into Z2. Multiplication can be done. A plus IB into C plus ID. We can multiply these two complex number. The same algebraic multiplication we can apply. AC plus IED plus IBC plus I into I is I square BD. AC plus. Now from these two expression, I'll take I common. ED plus BC. Then the I square. You know about these things. Just now I did. The value of I square is minus 1. If you substitute in place of I square, if you substitute minus 1, minus into plus, minus BD. Now then I can write this is equals to AC minus BD. First, real. Real means that which are independent of imaginary number. Now we can divide also this quantity for number 4 property. Z1 divided by Z2. Simply we can write A plus IB over C plus ID. If the complex number is in terms of numerator or denominator form, always that you have to rationalize the complex number, then only the simplified answer that you get. Now after doing this, now next is these two are the complex number. Now another property number 2, these two complex number may be equal. That means Z1 is equals to Z2. The complex numbers are equal. Then in this case, A plus IB is equals to C plus ID. Now if the two complex numbers are equal, then we can equate the imaginary and the real quantity. Imaginary and the real quantity. That means that over here, A is equals to C and can write B is equals to D. In case of two complex numbers are equal, then the real quantities are equal and imaginary quantities are equal. B must be equals to D. Now next property number 3, conjugate. But before doing the conjugate, now say Z equals to A plus IB is a complex number. I'll take an example of this. This is called real and this one is called imaginary, and we can represent it by RE of Z. REZ means the real number of Z means it is A. IM of Z means imaginary quantity of Z is B. You can read it like this also. RE of Z means the real quantity of Z. In entrance examination, you will get this kind of notations. RE of Z and IM of Z. RE means real number of Z is A and imaginary number of Z is B. With this, we'll discuss the conjugate. Let this one is a complex number. Let Z equals to A plus IB is a complex number. Z equals to A plus IB is a complex number. Therefore, its conjugate complex number will be, conjugate means Z bar. Z equals to A plus IB, its conjugate complex number will be. How to calculate the conjugate? You just have to change the sign of imaginary number. Now what is the sign of imaginary number? Over here, its conjugate will be A minus IB. This one will be the conjugate of a complex number. The property of conjugate. Now next, another important property that we'll discuss today. Now dear student, I am taking different example of complex number. Z equals to X plus IY. Find the modulus and amplitude or argument. It's the same thing. Amplitude and the argument. Now I'm not going to derive the formula over here. You just have to remember this formula. It's enough. After doing class 12 inverse trigonometry, then only you will understand these things. Now the Z equals to X plus IY. Find the modulus and the amplitude of amplitude and the argument. Now the modulus means mode of, first I am doing this. Modulus of Z means mode of plus IY. To calculate the modulus of a complex number, the complex number should be in terms of X plus IY or X minus IY form. The mode of Z equals to mode of X plus IY. Now when you remove the mode, mod of z. When you remove the mod, you just have to put a square root of x square plus, you don't have to write I over here, just write y square. This is the modulus of a complex number. If it is a plus iv, then you write under root a square plus b square. This must be the modulus. Now the argument and the amplitude is given by tan theta. Theta is the angle. Tan theta is equals to y over x, that we are going to calculate the value. And tan theta is equals to, this much means calculate the value of theta. Theta is the amplitude or the argument. Then we'll write, in place of theta we can write, or we can write this is equals to, theta is equals to, if you bring this tan over here, it will be tan inverse y by x. This is inverse trigonometry that you will study in class 12. Theta is this one, we can represent it by amplitude or argument is equals to tan inverse y by x. It is a angle. Now this much of theory today we'll discuss from the complex number. Now from next video I'll start solving the numericals of this chapter. Thank you.